Today's video is going to be about related rates, and this is going to be the first of two videos. We're going to start with a pretty typical related rates problem, talk about what it means, and then how to set it up. So this problem, a 12-foot ladder is leaning against a wall. The top of the ladder is 5 feet from the floor and is sliding down the wall at 6 inches per minute. The question is, how fast is the bottom of the ladder moving away from the wall? So just to think about what's going on, this is like my ladder. Got my ladder leaning against the wall, and we can imagine the top of the ladder sliding down, and as that happens, the bottom of the ladder slides away from the wall. That's the value that we want to find. So what we're going to do is figure out what formula we're going to use, set up the formula, find any missing values, and solve. So we've got to convert these words to a math problem. So when we distill the problem down to the math, this is what we have. We have a 12-foot ladder. That does not change. These are called related rates because we've got two values or two things that are changing. The ladder is sliding down the wall and away from the wall. This is an implicit differentiation problem. I'm going to represent the height of the wall is h, the bottom, how far the bottom of the ladder is from the wall is b, and when we say the ladder is sliding down the wall, I'm going to represent that as dh dt, the change in height with respect to time. The ladder does not change. That's why I labeled that as 12. That length stays the same. So what do I know? I know the height. My ladder starts off 5 feet off the ground. I know it's sliding down the wall, my dh dt. I said 6 inches per minute. I'm going to write that as negative because it's going down 1/2 foot per minute. What I want to find is dB dt. I think I'm going to need the length of b, so I'm going to use that for the Pythagorean theorem. But I'm going to solve for b using the Pythagorean theorem. So if my h is 5, I have 5 squared plus b squared equals 12 squared. So I end up with b squared equals 119, and b is the square root of 119. I'm going to leave it like that because ultimately I'm going to put everything in my calculator. Now I need to set up a function or a formula to solve for dB dt because that is what I want to find. That's how we represent the bottom of the ladder sliding away from the wall. When I see a right triangle, I always think two things. I think either Pythagorean theorem or trig. Since there's no angles here, I'm going to use the Pythagorean theorem, and I'm going to just set it up. H squared plus b squared equals 12 squared. H and b are both changing. Remember, the bottom of the ladder is sliding down the wall. The top of the ladder is sliding down from the wall, and the bottom of the ladder is sliding away from the wall. The ladder itself is not changing. Now I'm going to take the derivative using implicit differentiation. 2h, h is changing, so I write dh dt. Just like in regular implicit differentiation, we would write dy dx. This is the same thing, except it's with respect to time. Plus 2b dB dt. The bottom of the ladder is sliding away. So those are my two things that are changing. The ladder itself is not changing. So I can think of this two ways. The length of the ladder stays the same. The derivative of a constant is 0. Or if I multiply that out, I would just get 144. The derivative of 144 is 0. what we want to find is dB dt. So I've got a couple of options. I can either substitute my values in now and solve for dB dt, or solve for dB dt and then substitute in. I'm going to choose the latter method just because this looks pretty simple to solve. So I'm going to subtract, bring the 2h dH dt over, so I have 2b dB dt equals negative 2h dH dt, and then I'm going to divide by my 2b. I see that I can cancel the 2's, so dB dt, change in base with respect to change in time. Now I'm going to go and start substituting in. I see my h was 5 feet. So I substituted in the 5 feet for the h. I saw that my dH dt, how fast the ladder was sliding down the wall, was negative 1/2 foot per second. My base, we found using the Pythagorean theorem, was the square root of 119 feet. From here, it's just a calculator problem, and I want you to notice the feet cancel. So we end up with feet per second, which should make sense because we want a rate. We're solving for the change in base with respect to change in time. So since I'm going to put this all in the calculator, 5 times negative 1/2 is negative 2.5 divided by the square root of 119 feet per second. And when I put that into the calculator, I get 20.229, so I'm going to call that 0.23. So 0.23 feet per second. And if I want to change that to inches, I can just multiply it by 12, and that's about 2.75 or 2 3/4, 2.75 inches per second. So that's a basic problem using the Pythagorean theorem and doing sides. Next up, we'll use the same information, but we're going to talk about finding a missing angle.